This is the process where the solder mask is applied on the copper surface. The solder mask layer acts as an insulation layer, restricts molten solder to solder mask-free areas, masks off the copper layer, protecting it from chemical and abrasive damage during assembly, protects the board from dirt and fingerprints. Usually, a photo printing method like the photoresist application process is used. It requires the following steps: surface treatment of the copper layer, application of the liquid or dry film solder resist, pattern transfer using the solder resist photomask, solder resist development, resist curing. This process is done in the solder mask area while the UV exposure is performed in a clean room under yellow light. The machines and tools used are inspected etched panels, chemical clean line, pumice scrubber, dry film vacuum laminator or solder resist screen printer, baking oven, UV exposure machine, solder resist developer. The first step is to prepare the surface for the correct application of the solder resist. The panels are immersed in a series of baths to degrease and clean them. Then, an abrasive cleaning process is used to roughen up the surface and increase the adhesion of the solder resist on it. The panels are brushed and scrubbed with a pumice stone before going through a high-pressure water rinse and dry. Now it is the time to apply the solder resist to the roughened surface. There are two main categories of solder resist: dry and liquid film. Dry film solder resist is applied to the surface using vacuum laminators. The applied dry resist covers all the surface of the panel. Liquid solder resist is usually printed on the board using semi-automated screen printers. The machine applies the ink to the surface using a squeegee blade through a tensioned fine screen mesh. The mesh is patterned to avoid having resist inside the holes. The applied liquid film covers the surface of the panel except for the holes. The coated panels are pre-baked in an oven for a few minutes to stabilize the solder mask layer, before being transferred to the exposure room. The solder mask layer photomask is aligned on top of the solder resist and are placed on the vacuum frame of the exposure machine. Exposure time and level depends on the type and thickness of solder resist. During exposure, the resist under the clear areas of the photomask is cured by the UV light, while the rest remains unhardened. The exposed panels are transferred to the solder mask development line. The panels go through a series of chemical and water rinse baths to wash away the unhardened solder resist. After development, they are thoroughly dried. The final step is to post-bake the panels using thermal ovens to fully cure the solder resist. This is the process where the exposed copper patterns are coated by a thin layer of a solderable metal or organic lacquer to protect them from oxidation and corrosion. The standard surface finishes for PCBs are immersion tin, immersion gold, immersion silver, hot air solder leveling, electroless nickel immersion gold, organic solderability preservative. For this course, the cheaper and more popular immersion tin, hot air solder leveling and OSP finishes will be explained. The surface finish process is done in the plating area. The machines and tools used are: for the immersion tin finish, solder mask coated panels, immersion tin line, a variety of chemicals and lots of water. This is a chemically complicated process that requires several precisely monitored steps. It starts by chemically cleaning the panel to remove any copper oxides from the exposed copper. Then, the panels are rinsed with water before entering the micro-etching bath. This step is necessary to fully clean and slightly roughen up the exposed copper surface. Another water rinse step follows, before the panels enter the tin bath, where they will remain for several minutes. The tin-plated panels are again water rinsed before entering a bath with an alkaline cleaner to remove any residues from the solder mask. Then, they go through the final rinsing and drying steps. For the hot air solder leveling finish process, the machines and tools used are solder mask coated panels, pre-treatment line, HAL machine, post-treatment line. The solder used could be the standard eutectic alloy of 63% tin and 37% lead, or a lead-free solder alloy, for example, 99.3% tin and 0.7% copper. The process is done in 3 stages. During the pre-treatment stage, the panels are brushed, pressure rinsed, micro-etched, pressure rinsed again, and dried, before entering a water-soluble flux bath. The fluxed panels are manually loaded to the HAL machine consisting of the solder pot and hot air knives. The panels are dipped to the molten solder and pass through the hot air knives while withdrawn from the bath. The knives use hot air blasts to remove the excess solder and clear all holes. In the post-treatment stage, the panels are rinsed with warm detergent water to remove the excessive flux and clean the solder mask. Like all cleaning processes, this is done in several steps. For the organic solderability preservative finish, the machines and tools used are solder mask coated panels, OSP line, a variety of chemicals and lots of tap and deionized water. This is a relatively easy and eco-friendly process. The panels go through the standard degreasing and water rinsing steps before the micro-etching stage. Then the water and acid rinse steps follow. The clean panels remain in the bath with the OSP solution until they absorb the organic polymer. After several layers are formed, they are finally rinsed with tap and deionized water and dried. This is the process where the usually white markings on top of the solder mask are printed. Legends are mostly used to define component outlines with their identification numbers. Sometimes, the PCB manufacturer's marks, board ID, and batch codes are also printed. Legends used to be necessary in a time when components were manually soldered on the board and the PCBs were regularly reworked. In our time of SMT components and high-density boards, many PCB designers do not use them at all. There are 2 main legend printing processes. Direct printing, using inkjet printers, and silkscreen, using screen printing techniques. Sometimes, legends are printed before the surface finish process. This depends on the type of surface finish and preferred printing process. The process is done in the printing area. The machines and tools used are for direct printing, panels, inkjet legend printer, UV curable ink for PCBs. The process starts by loading the legend image file to the printer and placing the solder mask covered panels to the vacuum plate. Printing accurately so small markings on such a surface is not as simple as printing an image on paper. Those printers are equipped with cameras that scan the panel for predefined alignment fiducials and record their position. Once distances between the fiducials are measured, the legend image file goes through some sort of image processing to readjust its dimensions and make sure that legends are printed where they should. This calibration process is usually done thoroughly for the first panel in the batch and is repeated when the operator notices misaligned legends. Legend printers are also equipped with UV lamps that cure the ink directly after printing. In general, it takes a few minutes to print legends on one panel. The ink used for legend inkjet printing is designed specifically for PCBs. Those panels, and the legends on top of them, will have to be subjected to high temperatures during the component assembly process. The ink must be able to survive this and keep its color intact. For silkscreen printing, panels, PCB screen printing mesh and the machines to create the mesh stencil. Silkscreen printer, UV curing oven, UV curable legend ink for screen printing. This process is faster, cheaper but much messier than direct printing. The process starts by creating the silkscreen mesh for the specific panel that acts as a stencil. Silkscreen mesh is a specific polyester or nylon woven cloth mesh. It is woven in a way that allows small openings to be created between threads. The smaller the legend markings, the denser the mesh should be with thinner threads. To prepare the mesh, the operator cuts a piece that corresponds to the size of the panel and attaches it on a tension table where it is stretched to a specific tension value. Then, it is secured to a frame and coated with a photosensitive film. The legend artwork film is placed on top, and the screen goes through the screen exposure machine and a developer bath. Finally, the mesh is washed and dried. With the screen mesh ready and secured on the screen printer, the panels, and placed on the vacuum table, and a small quantity of ink is placed on top on the screen mesh. The printer moves the panel to the screen, and the squeegee pushes the ink through the openings of the mesh to the panel. The panels are collected and moved to the UV curing oven where they remain until the ink is fully cured. At the end of the process, the mesh frames are cleaned and kept in storage along with the artwork films for this specific PCB design. This is the process where the panels are checked for solder mask, surface finish and legend imperfections. For simple PCBs, a standard visual inspection of the panel by a trained inspector will suffice. It is recommended the panels are visually inspected after each separate manufacturing step. Regarding the solder mask, inspectors look for misregistration faults like partly covered pads and exposed tracks, surface scratches, blisters and impurities as well as partly cured areas. For the surface finish, the inspector looks for exposed copper patterns, possible short circuits and surface defects like scratches. The process is done in visual inspection positions present in each manufacturing area. These positions usually include a desk and a well-trained inspector with a good magnifying glass. This is the process where the mechanical holes, V-cuts, and other openings are created. The process is done in the fabrication area. The machines and tools used are finished panels, CNC router, CNC V-score machine, in the case of mass-produced PCBs, the boards are shipped in panels ready for the component assembly stage and are separated after the assembly. The cuts or openings that are created during this process must keep the PCB secured on the panel during the assembly, while allowing operators or machines to break the fixing points easily during depanelization process. There are two types of cuts. The first is to use a CNC router and drill to root clean throughout cuts around the panel, but leaving some fixing points. The second is to use a CNC scoring machine to create V-shaped breaking lines called V-cut. And of course, both cuts can also exist in one panel. This is the process where the electrical interconnectivity of the produced bare PCBs is checked. The process is done in the testing area. The machines used are produced panels, flying probe. The main purpose of this test is to check if all pads are connected to where they should be. The process is done automatically using machines called flying probes. Those automatic testers use the net list file of the PCB circuit provided from the customer, but adjusted for a full panel during DFM check, as reference. When the panels are loaded to the machine, two probes touch simultaneously the pads that are supposed to be connected and measure the resistance value. If the resistance is within a few ohms, the net passes the test. If not, there is an open. The resistance value between adjacent nets is also measured to ensure there are no short circuits. Flying probes can run many types of tests. The minimum requirement for compliance with IPC regulations is the standard net connectivity test. The others are performed under customer request. Thank you for watching our video. If you want to learn more, have a look at our other videos on how single double and multilayer PCBs are made.